5 Rules of Programming by Rob Pike. You spend a lot of time in coding, right? A lot of time thinking about it and a lot of time reading over the code and making sure that what you deliver is high quality. There's a challenge though, however, guess what? It takes a lot of your time and energy when it doesn't always have to, and it really shouldn't. As we take a look at these 5 rules of programming, we're going to sense a common theme throughout the rules, and we're going to walk through each one and we'll describe each of them. The first rule out of 5 from the rules of programming is you can't tell where a program is going to be spending its time, what amount of effort and energy the CPU is going to be needed for your algorithms. Bottlenecks can occur in surprising places, so don't try to second guess and put in speed hacks at the beginning. Now, what this tells me is that you should not spend time optimizing early. This is a common pattern that we hear in typical engineering design. Do not optimize early. Your efforts that you spend there might not be rewarded in the future, as bottlenecks will surprise you in various places, so there's no point in optimizing early in this case. Rule 2 in the 5 rules for programming is to measure. That's it, just measure. That's a really critical and important rule. What you typically hear these days are things like Prometheus and StatsD. You need to measure your code. This is application performance monitoring. It's absolutely critical and the most important part for figuring out where you need to deal with performance improvements, because until you've measured it, there's no point in spending additional time optimizing something that might not need to be optimized. Rule number 3 out of the 5 rules of programming is talking about algorithms, and the fancy algorithms are usually slow when n is small, and n is usually small under most conditions. What this means is kind of interesting, difficult to interpret, is that you can have these advanced algorithms that are really powerful and highly beneficial at high scale when n is big. You will have that opportunity. Essentially, it's saying that you can have these really great algorithms that really kick into gear when n is large, like when there's a lot of number of requests or a lot of number of activities that need to occur to accomplish a goal. Basically, what they're saying is that until you know that something is going to be needing to be a fancy algorithm, don't use fancy algorithms. Just keep things simple. And it goes a step further here in describing that even if you think that you need a fancy algorithm, do not add it in until rule number 2 is implemented first. If we remember back in rule number 2, it's simply a one-word sentence: measure. Got to measure those applications. Rule number 4 out of the 5 rules of programming is describing that fancy algorithms are buggier than simple ones, right? Fancy algorithms, they're more complex and they deal with more things and more cases and conditions that allow you to optimize how code and data is flowing through your program. You'll have to spend more time and effort to implement the fancy algorithm. In addition, when there is a bug, you're going to have more time having to deal with that fancy algorithm that you might not have needed in the first place. So we can use simple algorithms as well as simple data structures where at all possible. Basically saying 100% of the time, just keep things simple, go simple, and then we can deal with the fanciness later on in the future. One of the things I like about this, a common theme, is that Rob Pike uses the word fancy to identify algorithms, which is like a nice little, like a little poke saying, like this, like fancy algorithms. Rob Pike here is kind of poking fun at spending too much time on using and leveraging or creating these algorithms that you're most likely never going to need in the first place. Rule number 5 of the 5 rules of programming, which is our last rule, is that data dominates. If you've chosen the right data structure and organize things well, the algorithms will always be self-evident. Data structures, not the algorithms, are central to programming. This tells me that we need to keep a nice, simple application layer without going deep and creating a lot of code. Keep things simple. Do not go into abstractions as much as we want to, because we've learned these advanced techniques and technologies that allow us to abstract using advanced language techniques. But at the end of the day, those advanced language techniques are just not even worth it. They don't add any value. Even though we think we're adding abstraction that will allow us to optimize later, we can add more features, for example. In practice, this always tends to do the exact opposite effect. It makes it more difficult to later go back and update or manage or maintain and optimize how we write our code. Rob Pike gave us an excellent list of 5 rules of programming. We went through these here, And just to kind of walk through the details on those, the first two rules are all about Tony's mention of the famous premature optimization is the root of all evil. Optimization can mean many things, such as anticipating future changes to our code, creating these abstractions that allow us to go back. We might think that they're helping us in the future, but they're not. For example, even one of the services at PubNub, one of our APIs, ended up being 40,000 lines of Go code, which was insane simply because it was a data API that we're offering. And it was well architected and well engineered and a remarkable amount of abstraction that turns out was completely useless. We didn't need that level of abstraction specifically because it was just such a simple data API. It's an example of pre-optimizing in a way of the future, saying we can add more features and capabilities later on, but it turns out now that the code is optimized and abstracted into all these files and directories, and there's just too much. You have to touch so many different points in order to add a new feature into the system. It has counterintuitive. You have to keep things simple. Small number of files, no directories, keep the directories gone, keep things simple. Few files as possible, least amount of code. Another optimization here is that you can go in and talk about algorithmic optimizations where you see a high potential of CPU wastage. You might have an algorithm that's just inefficient and it will waste a lot of CPU. If you rewrite that in an algorithm that's more advanced, you can save that CPU. However, pretty much all cases, you never need to do that until later on, if ever. The remaining rules are in here. We see rule 3 and rule 4 here, as well as rule 5 is all describing one common thing of just keep things simple. This is the KISS. The KISS rule is all about keeping things simple. Overall, this list of rules is fantastic. I very much enjoyed it and align a lot with this because we need to always continue to focus on simplifying our time to market because that's critical. Additionally, we often find ourselves in situations where we might be inspired to write better code, which is great. Like, we need that inspiration. But at the end of the day, it turns out it's counterintuitive and it ends up hurting the team, it hurts the company, it hurts everything. Later on, it will hurt the sanity of whoever has to go back and maintain that code. So keeping things simple, no abstractions, just clean, simple, simple, simple.